All right, here we go. So we're going to do problem number 1. This is on page 330. Oops. So it says the sum of two numbers is 17. If one number is subtracted from the other, their difference is -3. Find the two numbers. So what we want to do is it says to let x represent one number, let y represent the other number. Use the given conditions to write a system of equations, solve the system, find the numbers. So here we are. We're going to go ahead and write a system of equations to represent these problems. All right. These ones are fairly straightforward. All right, but we just got to kind of read through it. So the first sentence says the sum of two numbers is 17. So what kind of an equation could we write for that? X plus y equals 17. The sum of two numbers, sum means plus. Okay, the sum of two numbers is 17. So there is our one equation. Now we have the second sentence. If one number is subtracted from the other, their difference is -3. What could we write for that? X minus y equals -3. Because it says if one number is always usually means equals subtracted, you know what that is, from the other, their difference is -3. So there's our two equations. All right. Now here you can pick any way you want to solve these. You could graph them, substitution, elimination, whatever makes you happy. How do you want to do this? Pick your method. Elimination. So to eliminate them, do we have to multiply anything by? No. Just add them. Because what's going to happen to the y's? They're going to cancel out. So we get 2x is equal to 14. And so x is going to be equal to 7. So there's one answer right there. All right. So you can pick any method you want. So we have x equals 7. And now I've just got to substitute that back in. And you can pick, either. Again, it doesn't matter which equation you pick. I'm going to go with the first one because what the heck. Nice and positive numbers. So I get y equals 10. So there's my two numbers right there. Okay. So that's how you do those ones. It's pretty straight. You just got to write little things for them and solve them out.
How did we get it? Oh, because 7 is already x.
So 1 through 3, I just saved you one. You already got one, and that's done. So now let's move on to 8 through 12. So that'll be the next block. All right, so now we're going to pick one from 8 through 12. These are using the graph, looks like from above. It says, in exercises 8 through 10, refer to the bar graph to visualize that your solution is reasonable. Okay, so pick whatever one you want. 8 through 12, we'll do it. 10? Okay. Is that the hardest one? There's one here that is kind of tricky. Let's see what it says. So we got a collection of Halloween candy. It contains a total of 12 Snicker bars and Reese's peanut butter cups. Chew on this. All right. The grams of fat in these candy bars exceed twice the daily maximum desirable fat intake of 70 grams by 26.5 grams. How many bars of each kind of candy are contained? There's one of these where it doesn't make any sense to write a system, so I wonder if this is the one. Let's see. We have a collection of Halloween candy contains a total of 12 Snicker bars and Reese's peanut butter cups. So the first thing we want to do on these ones, it's obviously getting a little bit harder, is we want to figure out what we want x and y to represent. All right, that's one of the things we want to do. So, what two things are they talking about in here? Snicker bars and Reese's peanut butter cups, all right? So, we want x to be one of those and y to be the other. It doesn't really matter which one. So, which one do you want x to be? All right, so that's going to be Snickers here. And Reese's. All right. Now, there's nothing wrong with using S and R for your variables if you want to. All right, except my S's always usually look like 5s, so I try to stay away from that. But we have this figured out. So now I'm going to go back through this and take a look at this again. All right, I wish I had like a magic wand I could make everybody like story problems and get them all right, but I don't. But you just kind of read through them and try to interpret what it's saying. The grams of fat in these candy bars exceed twice the daily maximum intake of 70. So let's find out how much fat is in the Snicker bars. How much fat do we have there? Look at the bar graph. 14. And how much fat do we have in the Reese's? 13.7. Okay. So, if I eat 2 Snicker bars, all right, how many grams of fat am I going to get? 28. So, I can write an equation that represents the amount of fat that I get from the Snicker bars and from the Reese's. So, I'm just going to do that for right now. So, the amount of fat that I get is going to be, how much do we get from Snicker bars for fat? No, just from eating one. A Snicker bar. 14. Okay? So we have 14x, right? Because if I eat x number of them, I'm going to get 14 times x, whatever that is. Right? Plus, how much fat do I get from the Reese's? 13.7. So it's going to be 13.7 y's, because if I eat 10 of them, I'm going to get 137 grams of fat from Reese's Peanut Butter Cups. All right? So that's what I have. Now it says that the grams of fat in these bars exceed twice the daily maximum fat intake of 70 by 26.5. All right? So what this is telling me is that the amount of fat I'm getting from eating all these bars is exceeding twice the daily amount. So if the daily amount is 70, then twice the 70 is going to be how much? 140. And how much does it exceed it by? 26. So how many grams of fat am I getting from eating all of these things then? 166.5. So I'm going to put that right there, 166.5. Now I have one equation already. Okay?
Hold on.
Yeah.
So to get 166, did we go 140 times 26.5?
We went 140 plus 26.5 because that's how much it exceeded it by. So there's one equation. All right? Now I'm going to go back up to this first one where it says a collection of candy contains 12. So how can I write an equation for that using the 12?
Where the x is.
Well, did I have 12 Snickers bars or did I have 12 total things? So x plus y equals 12. So there is my equation. So in the very first sentence, I had one of my equations. I just kind of bypassed it a little bit and jumped onto the first one, but I could have written one right away. But you always want to figure out what you want your variable to represent. All right? Okay. So here's my two equations. How should we solve them? We have 3 ways to do it.
I like elimination.
You like elimination.
But since there's because there's that like one.
Be easy to substitute.
You want to do substitution. Let's try that, okay? See, now this is where it's going to become your call on which way you want to do it. Like I said, some people like substitution, some people like elimination. All right, I'm not going to tell you which way to do it. I just want you to get it right. Okay, so if we're going to use substitution, which variable are we going to solve for? X. Okay, so I get x equals 12 minus y. Right? Are we good there? Okay, so now what are we going to do with that 12 minus y? So we're going to have 14, 12 minus y, plus 13.7y is equal to 1 166.5. So I took that bottom equation, because people like substitution, that was our method of choice, and we substitute this into here, and that's what I got. So now I just got to work through it. 14 times 12. Is that 196? Anybody done that one yet? 168. It's going to be a minus 0.3y, I think. I think so. Is that right? Okay, so then we're going to subtract this 168. Subtract the 168. $166.5 minus 168. That's not good. Back it up. Clear. There we go. Minus 168 equals negative 1.5. Okay, divide. Divide. What do we get for y?
5.
All these messy numbers and we get 5. Okay, that's because they made the problem up and I didn't. Yeah. All right, so we got 5 of what it was. Y was a P Reese's, and so how many Snickers are we going to have? Knowing that they got to add up to, how did I get 5? Oh, 7. Yeah, we're going to get 7 for X. All right. Okay, so that's a lot more challenging, obviously, than the first one. Okay, and I could have showed you an example, it wouldn't have been like that. So that's why I picking a block out. And the other one, that was a pretty tough one. The other ones are a little bit better. All right. Okay, our next little block. Let's see, 15 through 21.
Hold on, so
Sure.
the second part where it says negative, is it 1.5 equals negative 0.3?
Yeah.
So that's where I'm confused. How do we get 1.5?
166.5 minus 168. Okay. Any other questions? All right, so now I'm going to pick a block 15 through 21. Okay, these ones kind of vary a little bit, but they're somewhat the same. Got money in it, so pick one.
17.
I knew somebody was going to say that one. It has an A and a B in it. I thought they're going to pick 17. All right, we'll do number 17. Okay, so we're choosing between 2 telephone plans. Plan A, monthly fee with a charge. Plan B, monthly fee with a charge. Let's see. A wants us to know how many minutes of calls will cost. Will the cost for the 2 plans be the same? What will the cost be for each one? So let's go ahead and write this out. So we have plan A. Oh, man. I'm just going to go A here. So A is equal to, how do we find the answer for A? What's the equation for it? 17. So it's $20. And then they charge you,
5 cents per minute.
so that would be 0.05, say X, right? Okay, so that's A. What about B?
750 at $5.
And that doesn't change, right? It's always 5. Okay.
Yes. With 10 cents per month.
Okay, 0.1x, 0.05x. I'm thinking this up a little bit. All right. So part A wants us to know when these two plans are the same, correct? So this isn't really, I guess it's kind of a system, but kind of not. We can do it without really making a system out of it. What should we do with these two equations to figure out when they're the same? Yeah, you can graph it. What else? Couldn't you just set them equal? Set them equal to each other? All right. So we can do either way. We can graph it or set them equal to each other. You said graph, so it sounds like.
So how do we equal it?
So we go like this. So we would go 20 plus 0.05 is equal to 5 plus 0.1x. Oh, now you like that way.
Yes.
People don't like the graph. I've showed you that Desmos. It's pretty slick. Okay, we'll do it this way. Yeah, we're just going to set them equal to each other. And this really isn't a very good example of a system. But it kind of is, but mainly you can just do it this way. So let's do it this way. Oh, so what do we have to do to figure it out then? What are we going to do? We're going to do what?
Combine like terms.
Yeah, we're going to combine like terms, so move.
X to one side.
Okay, I'm going to move this one because it's smaller. And then we would subtract 5. And then you can divide it. I think you're going to get 30, but check it out. Did we get 30? It was 300. I want to check this out. 15 divided by 0.05. Gosh, darn thing. 0.05. Yeah, 300 is right. Okay. So there, 300 is the, let's see, they want to know, how many minutes? 300. I answered that one. What will the cost for each plan be? Well, let's figure that out. Okay, so let's just take, it doesn't matter because they're equal, so I'm just going to take the first one. So 5 plus 0.1 times 300. All right, put that in my calculator. That's going to tell me how much this plan's going to be times 300 equals 35. $35. So I answered the question. I got 35 or 300 minutes. And I got $35 for a cost. That's A. So B says, if you make approximately 10 calls per month, each averaging 20 minutes, which plan should you select? Does the 10 calls per month have anything to do with this? Yeah, because how much are they averaging? So how many total minutes would that be about then in this situation? 200. So I needed to know, how much I'm going to go. So I got 200 minutes. How can I figure out which one's the best for me? What would I do here? Yeah, plug in 200 for minutes, right? Yeah. Okay. So let's see, the one was, where did I got it? Here it is. So I'm going to put 200 into X for each one of those. All right, so take your calculators, put 200 in there, and see which one is best. This 200 minutes is how much I'm going to get in a month if I make 10 calls averaging 20. Not too many people call anymore, but... So let me know what you get for plan B and A. Did we get a plan A cost yet?
I think it's B, the better deal.
You think B is? How much did we get for A?
I got 30.
30? How much did we get for B? There you go. Yeah, I think you're right too. That was overwhelmingly getting the same answers, so that sounds good. So that ends 17. Sounds a good choice. All right. Not really a system of equations problem. I knew there was a couple that weren't. Okay, the next little block we're going to take a look at is 29 through 32. So we got to flip over to the next page. And we've got some investment problems. 29 through 32. Which one do you want to look at? 30. Okay, I'll show you how these work. They're kind of nice in that they give you a table. And these problems are old. They're not realistic or anything, but kind of cheesy in a way. Principal times rate equals interest. So they give you a chart to fill in, all right, which is really helpful, by the way. And on 30, it tells me my principal is X and Y, so it does that for me already. And it tells me my rate is 0.07, so I'll put that there, and 0.09, put that there. But to get that, it says you invested $20,000 in two accounts, paying 7 and 9. Good luck finding those. Annual interest. If the two interest earned for the year was $1,550, how much was invested at each rate? Begin by filling in information, then use the fact the interest for the two investments combined was $1,550. So we've got two accounts that we're going to invest money in, all right, 7 and 9, and we have a total of $20,000 that we're going to invest, all right. So one of my equations would be X plus Y is equal to 20,000 because I'm investing X into the 7% one and Y into the 9, and they got a total 20. So there's that one. All right? And they're telling us that if we take the principal times the rate, we're going to get this interest. So these two things multiplied together is going to give us the interest. So 0.07x and 0.09, y, sorry, is going to be my interest. So far, so good on filling in the chart. How much total interest do we make from this investment?
1,000.
Okay, so well, I'm going to take my interest that I get right here from these two, add them up, set it equal to 1550, and now I have two equations with two unknowns. And we can figure it out. We just have to figure out which way we want to do it.
So would it be 0.09y?
Yep. So which way you want to do it? Substitution, elimination, substitution. Okay. Which variable you want to solve for? Okay. So we're going to solve for y obviously in the first one. So we'd have y 20,000. Subtract the x. So now we're going to put that right into there. So I got that by doing some Sure.
How do we get 1550?
Because in the problem, it's
Okay.
it says that your total interest was 1550. Okay. And it kind of says on the end there, it says use the fact that the interest for the two investments combined was 1550. So it's kind of helping you out a little bit there. All right. I'm just going to keep grinding my way through this. 1550 minus 1800. Divide. So it looks like x is going to be 125,000. 12,500. And then it would be really easy to find y by just substituting that into there. Okay? And then you can get y. And that block of ones are pretty much like that. So when we get there, 75? Yeah. Okay? So hopefully this is kind of helping you, so when you're doing these problems, whenever you're going to do them, you can look at some of these examples that were right out of that block and use them to help you. Okay?
Okay, so
Good? Okay, one more, then we can jump into the supplement here. So the next block I gave was 37 through 40. And these ones are old-fashioned mixture problems. Okay? So, again, these aren't real realistic problems, but what the heck. So let's see, we got 37 through 40. Okay, so pick one out of there that you want to do. Again, we have tables, so it's kind of nice.
38. Which one did you say?
38. Okay, so here I got kgs for kilograms. I got some fat. And I got amount. I'm just going to call it amount. So like this, like this, like this, like this. Like this. So let's see, I got 20%. I have 15%. 16%. They used to have these in Math 60, actually. They took them out. And there was a different way of doing them. Okay. A candy company needs to mix 20% fat content of chocolate with 15% content of chocolate to obtain a mix of 16. That mix is going to be 50 kilograms. So that's why they have 50 right here. Because that's what they're trying to get. All right? Oh, I lost my train. Here we go. How many kilograms of each kind of chocolate must be used? That's the question. It says begin by filling in the missing entries in the table, and then we'll go from there. So we don't know how much 20% we're going to get. We don't know how many 15% we're going to get, so we put X and Y there. And it says that the number of kilograms times the percent. So this is going to be 0.2. This is going to be 0.15. This is going to be 0.16. Oh, come on, don't do that. There we go. So the kilograms times the fat equals the amount. Pretty much the same thing we just did. It's just different context. So this is going to be 0.28x, or 0.2x, sorry. This is going to be 0.15. Y. This is going to be 50 times 0.16. So I have to multiply that and figure out what that is. Okay. So I got the table all filled in. Are we good on the table part? Okay. So to write my equations then, I'm going to concentrate on this part here. Because I have an X and a Y in there. And this part here. So I have an X and a Y in there. Alright. So, what can I write? What's one of my equations going to look like?
X equals 0.2.
Now look at the ones that I did. Here's where your equations are going to come from. Here. And here. Okay.
So it would be 0.2x
Uh-huh.
plus,
Plus.
is it 0.15y?
Yeah, so 0.2x plus 0.15y equals 8. Okay, so what we're doing is we're grouping the same categories. So this is all amounts. So we're grouping the amounts and we're grouping the kilograms. Okay, kilograms makes one equation, amounts makes the other equations. We don't want to mix and match them because that doesn't work. All right, what about my other equation then with the kilograms? What do we got there? X plus Y equals 50. Very good. All right, so there's my two equations, and now I get to pick which way I want to do it. So, I bet you want to do substitution, huh? Okay. We'll solve for X this time, just for the heck of it. You do enough eliminations, you'll like them, but I can see why you're choosing substitution. Okay, that's going to go right there.
Are we solving for y?
You could. I solved for x. I don't know why I just decided to. So now we just got to work that out. So let's see, 0.2 times 50, I think that's going to give me a 10. Minus 0.2y plus 0.15y equals 8.
Should that be 10x or?
0.2 times 50. Did I lose an x? No, I'm good. Right?
You lost an x. X is
Because x was 50 minus y. So 2 times in there. So I just took 2.2 times both of those things. So we're okay. Two divided by 0.05 equals, I get 40 of them. Okay?
How do we get 0.5? So wouldn't it be negative 2.24? We move that to positive, so that to the 15, right?
Well, this is a 0.2y. So it's negative 0.2y plus 0.15y. So if you go negative 0.2 plus 0.15,
Okay.
we should get 0.05. And one thing that would make it easier, and I was going to mention this and I didn't, but you could make all these percents just regular numbers. We could have just went 20 and 15. And then you don't have all these decimals to deal with. Makes it a little bit bigger, but. So instead of having 0.2, 0.15, and 0.16, we could have just went 2, 15, 16, right? It doesn't make any difference in the problem. You're going to get the same answer. Okay, so what do we got here? Here we go. X equals 50 minus y, and we know y is 40, so ta-da, we did it. All right. So that gives you kind of an idea of how to do each block of those. So if you follow these, I think it'll help you out. Better than me just doing the examples out of the book, which aren't never always necessarily the same as the problems. Or making stuff up. Everybody's favorite. Questions on any of that? Okay. Finally, we're almost done. Hang in there. Let's see. They want us to do this supplement. So, do you have the supplement in the very, it's in the S23 section. Do you guys have that? Okay. So we'll do the 4.1 today, and then we'll do the 4.41 next time. So 4.1 is only, I'm not exactly sure what they wanted us to supplement these, but,
What page is that on?
well, it's way in the back on it, S23 or something like that. Yeah. So I'm going to try to get, let me do this. I'm going to pause this guy.